Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Hope you all well. Lecture for grade 9, subject chemistry, chapter number 6, exercise, lecture number 11, and I am Mrs. Saira Jamal. Today we are going to discuss the exercise of chapter number 6. Let's do the MCQs first. Number one, the maximum amount of sodium acetate that dissolves in 100 grams of water. In 100 grams of water and at 0 degrees centigrade, how much amount of sodium acetate is or sodium acetate can be dissolved? It is 119 gram. 119 grams of sodium acetate can dissolve in 100 grams of water at 0 degrees centigrade. And as you know that in my previous lecture, I told you that by increasing the temperature, the solubility of the solute also increases. So you can see that at 100 degrees centigrade, 170 grams of sodium acetate can dissolve in 100 grams of water. At 0 degrees centigrade, only 119 grams. And when we increase the temperature from 0 to 100 degrees centigrade, now you can see more solute can dissolve in this 100 gram of water. How much is that solute? 170 grams of sodium acetate. If we add this 170 grams of sodium acetate at 0 degrees centigrade, not at 100 degrees centigrade, at 0 degrees centigrade, then what will happen? At this temperature, out of 170 grams, 119 grams will dissolve and the remaining 51 grams will settle down at the bottom, because at 0 degrees centigrade, 100 gram of water can dissolve only 119 grams, not 170 grams. So the extra amount will settle down at the bottom. So which type of solution is this? It is unsaturated solution, saturated solution, supersaturated solution, or 1 molar. The correct option is saturated solution. Second MCQ, how many moles of sodium atoms are present in 2.3 grams of sodium? We have to find out the number of moles, okay? How many moles? And the given data is 2.3 grams of sodium. Mass has given. So mass is given and we have to find out the number of moles. Number of moles formula, you know, mass in grams divided by molar mass. Mass in grams are 2.3 grams and molar mass of sodium is 23. So 2.3 divided by 23 will give us the answer 0.1 mole. So 0.1 mole is the correct option. Third MCQ is, what is the mass of 5 moles of hydrogen gas? Now keep it in your mind that hydrogen exists in H2 form. Like hydrogen gas formula is H2, not only H. Most of the students, they make mistake by taking the molar mass of hydrogen 1. That is wrong. You have to take the molar mass of hydrogen 2, because hydrogen gas means H2. Okay. And we have to find out the mass. What is the formula of mass when moles are given? When moles are given, then formula of mass is equal to moles into molar mass. Moles, given moles are 5 moles, so we will put 5. Molar mass of hydrogen gas, I told you the atomic mass of one hydrogen is 1.008, but as we have two hydrogen, H2, so we will multiply it by 2. It will give us 2.016, and 5 into 2 will give us the answer 10.08 grams. So the correct option is 10.08 grams. Number 4, how many atoms are there in 28 grams of nitrogen gas? Like all these numericals, they are same like the numericals of chapter number 1, and you have done already those numericals, so I think this will be easy for you to solve. How many atoms are there in 28 grams of nitrogen gas? Again, nitrogen gas mean N2. Nitrogen gas N2, and we have to find out the number of atoms. For the number of atoms, we have formula number of atoms. First we will find out, as it is molecule, N2 is molecule, so we will use the formula number of molecules is equal to number of moles multiply Avogadro's number. But the problem is that in data grams are mentioned, no moles are mentioned. So first we have to find out the moles, and moles formula is number of moles is equal to mass in grams divided by molar mass. Mass in grams given are 28 grams, and molar mass of nitrogen, one nitrogen is 14, and I told it is N2. So you will put 2 multiply 14, which will give you the answer 28. So 28 or 28 will give us the answer 1. So 1 mole is the answer. Now if we put 1 mole in this formula of molecules, number of molecules is equal to number of moles into Avogadro's number. It will give us the answer Avogadro's number, because 1 multiply Avogadro number will give us the same answer. Now they didn't ask about the molecule, they asked about the atoms. So to find out the atom, first we have to see one molecule of nitrogen have how many atoms? 2 atoms of nitrogen. One molecule N2. N2 means there are 2 nitrogen atoms. So Avogadro number of molecules will have how many atoms? Because this answer is for Avogadro number of molecules. If one molecule of nitrogen has 2 atoms, then Avogadro number of molecules will have how many atoms? So we multiply Avogadro's number by 2. It will give us the answer 12.044 into 10 raised to power 23 atoms. So correct option is, the correct option for this MCQ is D. Okay, D is the correct option. Number 5, how many atoms are there in 0.1 mole of carbon? Very easy. Just put the formula of number of atoms is equal to number of moles multiply Avogadro's number. Number of moles are 0.1 and Avogadro's numbers are 6.022 into 10 raised to power 23. Then removing the decimal, we'll write 10, then multiply by Avogadro number divided by 10 will give us the answer 6.022 into 10 raised to power 22. You can do directly, or you can take this 10 up and then it will subtract minus 1 from 23. The answer will be 22. Only the difference is Avogadro's number had 23, but the answer is 22. Number 6, a solution of sodium hydroxide has concentration of 4 grams per decimeter cube. 4 grams per decimeter cube means 4 grams are present in 1 decimeter cube, or 1 decimeter cube you know is equal to 1000 centimeter cube. Okay, 4 grams are present in 1 decimeter cube or 1000 centimeter cube. So in 250 centimeter cube, what will be the mass? So 250 centimeter cube, the mass we have to find out. Then by cross multiplication, 4 into 250 divided by 1000, it will give us the answer 1 gram. So the correct option is 1 gram. Number 7, which of the following solution is more dilute? So lesser the molarity, more dilute will be that solution. 1 molar, 2 molar, 0.1 molar, 0.009 molar. So this is the correct option, because 0.009 is the smallest value. Number 8, a solution of sodium hydroxide contains 20 grams of this compound in 2 decimeter cube. Mass has given and volume is given 2 decimeter cube. What is the molarity of this solution? Very easy. You can find out the molarity by different formulas. One of the simplest formula is that first convert the grams into moles and then put it to the molarity formula, which is number of moles over volume in decimeter cube. So I'm using that one. Okay. First, find out the number of moles. So grams given are 20 gram and molar mass of sodium hydroxide is 40. It will give moles 0.5 moles, and by putting into the formula, molarity is equal to number of moles over volume in decimeter cube. Number of moles are 0.5 and volume in decimeter cube is 2 decimeter cube. So the answer is 0.25 molar. C is the correct option. I forgot to encircle it, but C is the correct option. Number 9, which quantity is same for 1 mole of hydrogen gas and 1 mole of water? This is same like the chapter number 1, the MCQ. That is for 1 mole of all the substances or for all the gases, molecules are always same. Number 10, if 1 mole of sodium contains X atoms of sodium, what is the number of moles contain 46 grams of sodium? So first of all, we have to find out moles. So mole formula is mass in gram divided by molar mass. 46 over 23 will give us 2. So 2 is the moles. 1 mole has X atoms, so 2 moles will have how many atoms? Definitely 2X atoms. So 2X atom is the correct option. Short question answers. Question number 1, differentiate between saturated and unsaturated solution. And I told you we have to write at least 3 points of differences. So the first point is a solution which can dissolve no more solute in it at a particular temperature is called saturated solution. This solution is already saturated, already it has greater amount or greater concentration of solute in it, and the extra amount settle down at the bottom in the form of chunks or in the form of grit. So they are already saturated. So a solution which cannot dissolve more solute in it at a particular temperature is called saturated solution. And unsaturated solution, a solution which can dissolve more solute in it at a particular temperature, is called unsaturated solution. Unsaturated solution has the capability to dissolve more solute in it because it already has lesser amount or lesser concentration of solute in it. Second point, adding more solute can change the appearance of solution. Definitely, if you will add more solute in it, so more solute will settle down at the bottom, and then what will happen, you can see chunks or grit of that solute in the bottom. And in this case, if you add more solute, it does not change the appearance of solution because all will get dissolved and nothing will happen to the shape or the appearance of the solution. Third point, solute is present in greater concentration, and already saturated solution has greater concentration of solute in it, while solute is present in lesser concentration in unsaturated solution, so it can dissolve more solute in it. Question number 2, give examples of a solid solution containing two solids. Uh, Solid in solid solution, one is brass. Brass is an alloy of, what is alloy? Alloy is the mixture of two or more metals. So brass is an alloy of two metals. Those two metals are copper and zinc. Okay. Second example is steel. Steel is an alloy of iron and small amount of carbon and silicon in it. And gemstone like ruby and opal, they are also solid in solid. In these solids, solute dissolve in solid solvent. So we call these solutions solid in solid solutions. Question number 3, can you call colloid a solution? Colloid, I told you that it is a heterogeneous solution, and with the naked eye it looks like true solution, but actually when we see it under electron microscope, so it still contains some suspended particles. So due to the presence of those suspended particles in solution, we call it false solution. False solution. But we can call it solution because it is a heterogeneous solution or it is a false solution. So the question is, can you call colloid a solution? Answer is yes. Colloids are heterogeneous solution. Heterogeneous, I told you that, where hetero means different and genus means phases. They have different phases, or the particles are not distributed uniformly. Their particle size vary from 1 to 10 is for 3 nanometer, and they looks like true solution with a naked eye but contain suspended particles when seen under electron microscope, hence are also called false solution. Examples are milk, fog and blood. Question number 4, gasoline does not dissolve in water. Why? Gasoline, petrol is also called gasoline and it is insoluble in water. Why? There are two factors on which solubility depend: nature of substance or structure, and second, intermolecular forces. So gasoline, also called petrol, is an organic compound, carbon containing compound, and is non-polar. I told you in my previous lecture that mostly organic compounds are non-polar in nature. Its structure is totally different from water, and intermolecular forces in water are hydrogen bonding, while in gasoline, the intermolecular forces are the London dispersion forces, which are weak forces. So due to the difference in the type of intermolecular forces and polar and non-polar nature and difference in structure, a gasoline does not dissolve in water. Are gemstone solutions? What are gemstones? Gemstone is a piece of mineral crystal which is used to make jewelry and other adornments and are solution of solid in solid. For example, many naturally occurring stones like ruby is a solution of chromium ion in corundum crystal. Corundum crystal and chromium ion both are solid in state. And opal are solid in solid solution. So the answer is yes, gemstones are also called solution and they are solution of type solid in solid. Question number 3. A tiny crystal of solid substance is added to an aqueous solution of the same substances. What would happen if the original solution was supersaturated, unsaturated, and saturated? Suppose we have three test tubes. In one test tube, we have saturated solution. In second test tube, unsaturated, and in third test tube, saturated solution. And if we add a crystal of the solid from which that solution is made up of, what will happen to the test tube which contains supersaturated solution? I told you when you add crystal of the same salt in supersaturated solution, crystallization will start, crystal formation will start. And in unsaturated solution, the crystal will dissolve. And in saturated solution, the crystal will settle down at the bottom. So by doing this test, you can identify that the three test tube, which test tube contains supersaturated solution, which test tube has saturated solution, and which test tube have unsaturated solution. Question number 4. Explain why methanol is soluble in water, but benzene is not. Methanol is organic compound, benzene is also organic compound. Then why methanol is soluble in water, but benzene is not soluble in water? Methanol is soluble in water due to two factors. First factor is due to hydrogen bonding. If you remember in previous lectures, we discussed that methanol, due to similarity in structure and polarity, it can make hydrogen bond with water and hence is soluble in water. So same is here, methanol due to OH bond and due to the polarity of this OH bond and due to similar structure with water and due to making hydrogen bond with water, methanol is soluble in water. Benzene is organic compound and is non-polar and has weak London dispersion forces. So all three things are different. Nature is different, it is non-polar. Second, polarity, it is non-polar. Second, structure is totally different from water. And third, the intermolecular forces are London dispersion forces, which are weak forces. So due to all these three differences, methanol is soluble in water, but benzene is insoluble in water. Question number 5. How can you prepare 250 centimeter cube of 0.5 molar magnesium sulfate from a stock solution? Stock solution, I told you, the concentrated solution or the solution which is available in lab and has high concentration is called stock solution, and we can prepare a dilute solution from this stock solution. And definitely we will use dilution formula, M1V1 is equal to M2V2. Now let's see the data. We have to prepare to 50 centimeter cube. So the required volume I told you V2 is the required volume, it is 250 centimeter cube. And the required molarity is 0.5. So M2 is 0.5 molar. Stock solution molarity or M1 is 2.5 molar, and V1 we have to find out. So V1 is equal to M2 V2 over M1 by putting the values in the formula. By putting the values in the formula, before putting the values, we have to convert 250 centimeter cube into decimeter cube. So 250 divided by 1000, it will give us the answer, but you can also put it in directly, but the answer you will get in centimeter cube. So no problem. We can do like as such, just put 250 centimeter cube and then zero point 0.5, which is the required molarity, and 2.5 is the molarity of the concentrated solution, you will get the answer in centimeter cube, which is 50 centimeter cube. If you convert it into decimeter cube, answer will be in decimeter cube. Okay. Question number 6, a table has given and we have to complete the option. First one, mass of solute is given 20 gram, moles of solute, we have to find out volume of solution as given, we have to find out molarity. So mass of solute given is 20 gram, volume of solution given is 500 centimeter cube. We will convert it into decimeter cube dividing by 1000. It will give us 0.5 decimeter cube. Number of moles of solute we can find out by using the formula mass in gram divided by molar mass of sodium hydroxide. So answer is 0.5 moles. And now we will use molarity formula, number of moles over volume in decimeter cube. So number of moles are how much? 0.5 mole, and volume after converting into decimeter cube is 0.5. Answer is 1 molar. Okay, so we get number of moles 0.5 and molarity 1 molar. Okay, answers are here 0.5, number of moles, and molarity 1. Number 2, B part moles of solutes are given 0.25 and molarity is given 0.1. We have to find out volume and mass. Okay. Moles of solute given are 0.25 moles, molarity given is 0.25 molar, and volume of solution has not given. So what we will do, molarity means 0.25 moles per decimeter, because molarity, you know, it is equal to moles per decimeter cube. It means the volume is 1 decimeter cube, and we know that 1 decimeter cube is equal to 1000 centimeter cube. So we will use volume as 1000 centimeter cube. Mass of solute we have to find out. So mass in gram is equal to number of moles multiply molar mass. You know this formula. Number of moles are 0.25 and the molar mass of sodium hydroxide is 40. 10 grams are the answer. This is first part. Second, we have to find out the molarity. So molarity in the third case, okay, they ask volume. So volume we will write 1000 centimeter cube or 1 decimeter cube, and they ask mass in grams, so it is 10 grams. Okay. Part C. Part C, volume is given 200 and molarity 0.1. We have to find out moles and mass. Okay. C part, molarity given 0.1 molar, volume of solution 200 centimeter cube. I told you to convert it into decimeter cube divided by 1000. So 0.2 decimeter cube. We have to find moles of solute and we have to find mass of solute. So first we will find out moles of solute, which is equal to molarity into volume of solution in decimeter. It means we will use the molarity formula, and from that we will take out moles of solute. So molarity given is 0.1, volume of solution 0.2 decimeter cube, answer is 0.02 moles. Now we will find out mass. So mass of solute formula, you know, moles into molar mass. Moles are 0.02 and molar mass of sodium hydroxide is 40. So 0.8 grams is the answer. Question number 7. Give examples of the following solution: a liquid solution of a liquid solvent and gaseous solute. It means solute must be gas and solvent liquid. So gas in liquid. Gas in liquid, first example is soda water. Soda water, you know, carbon dioxide is dissolved in water. And second is hydrochloric acid. So hydrochloric acid is chlorine gas dissolved in water. Okay. Also you can take hypochlorous acid or hydrochloric acid. So this is gas in water, which is an example of gas in liquid. Second, a solid solution of two solids. Brass is an alloy of copper and zinc. Steel is an alloy of iron, which contains small amount of silicon and carbon. Gemstones, I told you, ruby, opal, they are also example of solid in solid. Question number 8. What is the molarity of solution prepared by dissolving 1.25 grams of HCl gas into enough water to make 30 centimeter cube of solute? Now you can also use this formula. Mass of solute given 1.25. Molar mass of solute. Solute is HCl. So a molar mass of HCl is 36.5 and 1000 volume is in 30 centimeter cube. We will put the values and after solving 1.14 molar is the answer. Question number 9, again same like formalin is an aqueous solution of formaldehyde. Formaldehyde is an organic compound. You can see HCHO. When we dissolve it in water, it will give us formalin. The solution is called formalin, and this formalin we use to preserve the specimens, biological specimens like the animals and plants. We can preserve them for a long time. So a biologist wants to prepare 1 decimeter cube of 11.5 formalin. What mass of formaldehyde he requires to form formalin? How much mass of this formaldehyde he requires to make this required solution? Volume given is 1 decimeter cube, also equal to 1000 centimeter cube. Molarity required is 11.5 molar. Molar mass of formaldehyde from formula HCHO, hydrogen 1, carbon 12, hydrogen 1 and oxygen 16. So 30 gram. Mass of solute we have to find out. So molarity is equal to formula and then molarity is 11.5. Mass of solute we have to find out. 1000 and volume again is 1000 and molar mass of solute is 30, and then by cross multiplication or taking out mass of solute 11.5 multiply 30, so 345 grams. 345 grams are required to dissolve in 1 decimeter cube or 1000 centimeter cube will give us the required molar solution, which is 11.5 molar. Question number 10. A solution of calcium hydroxide is prepared by dissolving 5.2 milligram. First, we have to convert the milligrams into grams. Okay. So by converting milligrams into grams, we will get the answer 0.0052 grams. And total volume is 1000 centimeter cube. We have to find out molarity. Just by putting all these values, mass of solute, which you convert from milligram into grams, molar mass of solute, molar mass of solute, we found it over here. Calcium 40, plus there are 2 oxygen atoms, so 2 into 16, plus there are 2 hydrogen atoms, so 2 into 1, it will give us 74 grams. By putting the values, you will get the answer 0.00007, or you can also write it 7 into 10 raised to power minus 5 molar. Question number 11. Calculate the number of moles of solute present in 1.25 centimeter cube of 0.5 molar phosphoric acid or phosphoric solution. We have to find out the moles, okay? And volume mentioned is 1.25 centimeter cube. We will convert it into decimeter cube, and molarity is 0.5 molar. Number of moles we have to find out. Molarity formula, one is this one. There are like different ways of showing molarity. You can use this formula, or instead of writing this mass over molar mass, which is the number of moles, so you can use number of moles. You can use number of moles, or you can open number of moles by writing mass or molar mass. Both formulas are correct. Okay. So in this case, as mass is not given. If mass is given, you can use this formula. But if moles are given, then definitely you will use this formula. So molarity is equal to number of moles or volume in decimeter cube. Number of moles we have to find out. Molarity is 0.5, and volume, which we convert from centimeter cube into decimeter cube, is 0.00125. After solving, we will get the number of moles, which are 6.3 into 10 raised to power minus 4 moles. Question number 12, calculate the new molarity. Again, this is the dilution formula. New molarity when 100 centimeter cube of water is added to 100 centimeter cube of 0.5 molar HCl. Very important question, dear students, and mostly the students, they make mistake in this question by writing the volume. They write 100 centimeter cube volume, but keep this in your mind that 100 centimeter cube volume was before, and then we add more 100 centimeter cube in it. So 100 plus 100 is equal to 200 centimeter cube. Okay, so V1 you have to write 200 centimeter cube, not 100 centimeter cube. Okay, this is the main mistake which mostly the students they make. Given molarity 0.5, and then volume you have to find out. So V2 is volume is HCl 100 centimeter cube, which we have to prepare. The previous one was 200 and this is 100. Okay. Now, by putting the values in the formula, you can get answer 0.25 molar. 0.25 molar is the answer. Very important question, I told you, but be careful about the volume. V1. Question number 13. How are solution useful for society? Give 3 examples. I told you that air is a solution, gas in gas, soft drinks are solution, juices, shampoo, petrol, natural gas, diesel, kerosene, cough syrup, and many other. These substances are solutions, and definitely we use them for different functions. Most of the chemical reaction that takes place in the bodies of living organisms occur in aqueous solution. Definitely they are present in the form of solution. And brass, steel, German silver are also solution. These solutions are widely used for making cooking utensils, surgical tools, cutlery, musical instruments, and many other objects. Okay, so these are about 3 examples of solutions which we use in society. uh, Hope you understand this exercise. Think tank is left, so inshallah we will do think tank in the next lecture. Try to complete your notebooks, learn these questions properly, and if you have any problem you can ask me through the WhatsApp group. Thank you.